Okay, I prepared a piece of 15mm PVC, and as I'm going to do a full profile cut on it, I'm going to glue it down on a sacrificial plate. In this case it's an old template from my Pantograph machine. I don't need the backside to be perfect, so I can use it as a sacrificial plate. And I clean both parts with isopropane alcohol, and once it flashed off, I'm going to use some double stick tape to hold this part down. Okay, I set the Pantograph machine to a ratio of 1:1, so my part on the template table up here gets exactly duplicated down here on the machine table. This is a bit sketchy of an operation because when you do 1:1 ratio copy milling, you get the whole cutting forces of the end mill also down on the stylus, and it's a real bear to hang on, and it will get into chattering. Here we are up at the template table, and as you can see I just bolted down the aluminum part, that's my template, down to the template table, and I have a stylus with 7mm in diameter installed. I'm using a 6mm end mill, so the 7mm follower here will give me some stock allowance for a finishing cut. So I had the pantograph set up slightly wrong, and for that reason the part came out a bit, not as it should look. But fortunately I had some material left, and I cut out a new one. I already did the profile cut, a roughing cut. And a roughing cut on a pantograph is exactly that. It's super rough. As you can see, surface finish is really not good. Okay, I moved the whole sacrificial plate with the part on it over to the milling machine, and I machined out the interior using a 6mm end mill and boring head. I think I did this off camera. I scrubbed the line to the outside 2.5 mm offset, and then I just roughed away all the material, and then I took a finishing pass all around. So let's take this off the machine and try to unstick it from the sacrificial plate. Okay, I took the cover over to the bench, I ran it over the chamfer milling machine, and then I rounded the chamfer over with some 240 grit wet paper. Then I went through all the grits of my micro mesh paper, starting at 150, going up to 1200, and that's the result I got. It's not perfect. There are a million small scratches that would have been polished out with the lower grits, but that's plenty good enough for a belt cover, and it fits over. Has exactly the same dimension as the aluminum plate. And we will just run 1 or 2 screws through it to hold it in place. Some 3 mm countersunk screws. And then we have already the belt covered and protected, and also my fingers protected from going with the belt through the through the belt gear. That hurts like frick. So that's the belt cover. I didn't bother cleaning up the inside very much. All the milling marks are still there. So I drilled the belt cover off camera, just laid out 2 holes, drilled them and transferred them to the aluminum plate so I can screw it together, but as the belt cover is hollow, when you tighten down the screw, you will deform the belt cover very heavy. So I'm doing what's usually done in injection molded parts. I'm adding a dome over the holes. So I had some plastic spacers. I think these are PVC too, and they are for a 3 mm screw, and I'm just going to glue them centered over my 3 mm holes, so I have some standoffs and I can tighten down the screws as much as I want. And I don't have a PVC glue in the shop, but I have, of course, super glue, and I did a test joint here. I just took a piece of PVC scrap and I butt jointed one of the spacers up against the PVC, and this holds pretty good. It won't get any bending forces, it will only get compressed, so this should be perfectly fine. There we go. Now we can tighten down the screws like crazy. What I'm going to do is I will take some super glue and I will create a fillet around these 2 domes to reinforce them. I wanted to weld glue the PVC with acetone, which works with polystyrene perfectly fine, but the PVC doesn't even get scratched by the acetone. I was quite surprised. I never tried that before, and I really thought that this might work. I have to get some PVC glue for the future. But for this case, the super glue will be perfectly fine. Okay, this is the aftermath to the Quill feed. As you can see, I added some things. You will see the video on the dial ring sometimes in the future. I have a separate video where I make the graduations of the style. And I also modified a plastic housing to fit around the motor, which contains the electronics, and it has a display which shows the feed rate and so on and so on. It runs with a small Arduino Nano microprocessor board, and it has a stepper control or a PWM controller in it, which drives the motor. And everything is hooked up to a 24 volt power supply that I already had for the X-axis power feed on this milling machine. And everything is powered by the main power switch on this milling machine. And this powers on the DRO, the power feed for the X-axis, the machine light, and also the power feed. As you can see, I have a switch up here which turns on the motor, and it's feeding, or it wants to feed, but of course we still have the clutch disengaged. And I have a poti up here which controls the feed. This display shows the feed rate of the quill in millimeters per minute. And it reads the actual speed of the shaft. I have a magnet in the worm wheel, or in fact it's 15 magnets, and I have a Hall effect sensor which takes the signal of the timing belt gear and lets it go into the Arduino and do some magic and give me the actual feed rate. It goes up to 60 millimeter per minute. I can go down to about 10 millimeters per minute. That's a good range. I can do pretty much all machining tasks, drilling, boring, reaming with this feed rate. Yeah, you set your speed, like let's say 30 millimeters per minute, and you engage the power feed and you're good to go. I don't have a specific end switch, but the conical clutch here will slip when I hit the end of the travel, i.e. the depth stop of the quill. Let's see, I made a Sharpie mark here, and now it's slipping. That means the quill stands in position and the worm drive still moves on. Of course, the motor bogs down slightly when it runs up against the stop and has to overcome the friction in this clutch. But that's a pretty good safety device. And that way I can also machine up to a shoulder when I bore a blind hole. And I'm pretty sure you all want to see the inside of this housing. There we go. That's all the mess inside. I have an Arduino Nano controller board down here, just soldered to a piece of very board. A few header connectors which go to the display, to the motor driver back here. This is one of those El Cheapo L298N motor controls, which can either run a stepper motor or a DC motor via speed control, with PWM speed control. And I have a Hall effect sensor in here which reads the speed of the timing belt. All this, I'm absolutely no electronics guy, and I just bought the modules off eBay. All these parts are Chinese specials. The Arduino cost about €2. The motor controllers are $3. The display unit, which is also very easy to set up, is about $3 too. And all the other stuff I had lying around. Only the case was $5. Had to order that from a proper supplier. And that's the whole setup. I will someday in the future release the wiring setup for this, and also the source code, which is a blatant mess. It's copied together from Arduino example projects and a tachometer project that was released in a German machinist forum. So I will add that someday down in the link in the description, but not for now. I'm happy that it runs that way, and I don't want to mess with anything in here at all. So let's get this back together. And I had to I had to relieve some of the housing in here to make room for the headers of the display and the mini USB on the Arduino. Let's get this closed up before somebody can take a closer look at the horrible mess we made with the electronics. And of course, the Arduino is nothing for a real electronics project, but for me it's an easy way to get up and running without having to mess building, selecting a microcontroller, setting it up on a piece of PCB, getting all the external parts to run it and set up a development environment on my computer. I just hook it up to the micro USB of my computer and I can do the programming. So that's it for the Arduino. I like them. Okay, we're doing a quick test cut with a 20mm drill bit, drilling some C45 carbon steel. I'm running the drill bit at 300 RPM and I'm feeding 15mm per minute. That gives us a chip load of 0.05 per turn, per revolution. So let's go. And take a look at those beautiful chips. Okay, I changed to my boring head and I'm just going to take a mild pass on this hole we just drilled to make it a bore. You know, the difference between a bore and a hole is the hole is there somewhere and it has some diameter, and the bore has a diameter and is on location. So let's see, we will run this at 580 RPM. There we go. Now we can retract the tool while it's at a halt. Take away the chips. Okay, I did a second cleanup pass. Very same feed but shallow depth of cut. And as you can see, the surface finish back here on the inside of this bore, it's rather good. And that was one of the main reasons I wanted to have a power feed on the Quill. With boring small holes, or boring in general on the milling machine with boring head, you want to have a constant feed, otherwise you will see it in the surface finish. No matter how steady your hand is on the hand-operated fine feed of your Quill. And I think with the power feed I got that sorted out now. But I still don't like to use the Quill to do heavy boring. That's a job to raise and lower the whole head of the milling machine. The dovetail ways of the C-axis movement can take much higher loads than the small diameter quill. And for heavy cuts, I move the head. For small diameter boring and for finishing cuts, I'm perfectly fine to use the quill. Especially when I have, as I have the power feed together, a really good finish. And it also helps with tolerances when you have a constant feed, because everything is constant. So I hope you enjoyed this short series on making the power feed. And yeah, thank you all for watching and see you next time.